Hello, in this video we're going to look at the claims made in many YouTube videos that the moon has strangely tilted or rotated on its axis in a way that it should not be. This is explained quite simply when we consider that the moon rises in the east, travels across the sky and sets in the west. In the northern hemisphere the moon will cross over in the southern sky, and in the southern hemisphere the moon will cross over in the northern sky. I am in the southern hemisphere. Let's have a look at this video of this Concorde aircraft flying across the sky from east to west as if we are looking north. This is the sort of view that we would have from the southern hemisphere if we were comparing it to the moon. Let's take another look, and we'll take some photos this time as the aircraft fly over. Pointing northeast, pointing north, and pointing northwest. Now let's take a look at our photos. We can see now that the angle that the aircraft are pointing in our photographs are quite different in each photo. And in exactly the same way we will see that the moon appears to change its angle as it travels across the sky. Thank you for watching. Please be sure to check the description box for a link to our discussion page, Voices of Reason to Explain X or Vortex. Thank you. Okay, here we are looking at Starry Night Pro. I've got Starry Night set to Raleigh, South Carolina, United States. According to Catfish's profile, he lives in South Carolina, so this will be his view from around about that area. This is the 14th of August 2013, set at 1:26 p.m. Local standard time. I have not set this to daylight saving time if that's the case currently. Now I've got the moon selected and centered, and we can see this red box which I'm going to zoom in on. This red box is to simulate a field of view of a digital camera or a video camera as we take images of the moon as it rises and crosses our sky. Okay. Now remember that the bottom of this red rectangle, our field of view, is always going to be level with and parallel to the horizon. This is to simulate what happens when we take a photo, because unless you're doing something funny with your camera like turning it on an angle, then normally when you take a photograph your feet are firmly planted on the ground. You hold your camera with the bottom of the camera parallel to the ground whenever you take a photo. It doesn't matter whereabouts an object is in the sky, normally the bottom of your camera will be parallel with the ground. So this red box is to simulate our field of view. Okay, I'm going to zoom in so we can clearly see the moon. Now obviously it's in the early afternoon at the moment, so the moon is rather hard to see, so I'm going to turn off the daylight so we can get a clearer view. Now we can see that on the 14th of August the moon was at first quarter. As we can see in the information on the left hand side, it says first quarter 7.71 days old. Okay, now the green line that we see is the orbit line of the moon. The illuminated part of the moon obviously is always facing the sun. The line between the illuminated side of the moon and the dark side of the moon, this boundary here, is called the terminator. The terminator is always perpendicular to the orbit line, and it will always be perpendicular to that line regardless of the position of the moon in the sky. Okay, now I'm going to turn the daylight back on so we can have a proper simulation of what's going on during the day as we progress through the hours, and I'm going to run this forward. Now the time is 12,000 times faster, so we're running this forward. I'll zoom that out so we can see the horizon. Remember that the bottom of that red box is always parallel to and level with the horizon. So we can see that the moon is now at about its highest point in the sky, and now it's coming down the other side, and the bottom of that red box is still parallel and level with the horizon. Okay, so we're coming up to 10:50 PM on the 14th of August. Now if I zoom in, you can see how much the angle of the moon has changed there, but the illuminated side is still facing the sun, obviously, and the terminator line, this line here, is still perpendicular to the orbit line. I'm going to zoom out, and I'm going to run this backwards to our starting point as we were, and again the bottom of that red box is level and parallel to the horizon. Okay, so we're coming back to our starting point. Back to about 1:30, 2 o'clock in the afternoon. Okay, now I'll zoom in. Once again, the bottom of the box is parallel to the horizon. I have to stress that. I'm going to zoom in so we can see the moon, and I'm going to turn off the daylight this time. Remember, even though it's dark, it's still 2 o'clock in the afternoon. So I'm going to run this forward again, and this time we can see more clearly because I'm zoomed up and the daylight is off. We're going to look at the angle of the moon, the apparent angle to the observer. So as I run this forward, we can see that apparent angle is tilting over, and that terminator line is coming up to perpendicular from our point of view. It's rotating clockwise, and now it is tipping over, and I believe that this is what Catfish is talking about. But this is simply caused by field rotation, as has been explained previously. Now we're seeing the horizon scenery coming in there, so if I zoom back out, we will see that that's actually part of a roof line. So I'll back that up so we can see the moon again. I'll stop that, we'll zoom in, and we can see that the bottom of the red box is still parallel to the horizon line. And this is what we would get if we were taking a photo of the moon, or we were looking at it with our eyes. We have the same perspective as taking a picture through a camera, a video camera or a digital camera or whatever. So we can see that the moon has apparently rotated through the sky, but again this is simply caused by field rotation, as has been explained previously. It's not because the moon is doing a flip by 180 degrees, it's not because the sun is playing hopscotch, as Catfish has said it isn't, and it's not because the moon is cycling through 28 days of lunar phases, as Catfish has suggested is happening each night. It is simply because of field rotation, as has already been more than well and truly explained, but no doubt this explanation won't be enough as well. But anyway,
When I enrich Mr. Thrive and Survive, caught the rapid counterclockwise rotation of the moon on February 16, 2019. It was a truly amazing, once-in-a-lifetime discovery. It was so damaging to the heliocentric model that hardcore globies didn't know how to explain it away. Some of them said things like, "Really? 2,000 years of astronomy by thousands of people all over the world, and the great Mr. Thrive and Survive is the first and only one to catch this event?" Others claimed that we faked the footage, bumped the camera, or that it was field rotation. This video is to answer all of those points, leaving the ballers with nothing but the actual observational evidence that their worldview has been utterly destroyed. This time-lapse of the event that you're watching represents more than 7 hours of continual footage, from 4 in the afternoon till almost midnight. Notice that the Sea of Crises remains in place for the entire time, except for the rapid jump. The only way that can happen is if the cameras were attached to equatorial mounts, which absolutely prohibit field rotation. Let me try to explain what that means. Hi, I'm going to show you the difference between an alt-azimuth mount, which is on this telescope, and an EQ mount, which has got the P1000 on it. The alt-azimuth will give you field rotation. Hold on a minute. Because you've got a picture, it's like you standing there. All right, the base is your feet. You're turning to your left, you're turning to your right, and then the top axis. So you got two axes of rotation. The bottom one will move left to right, and then the top one will be like your neck tipping up and down. So if you, okay, let's say you see the moon coming up in the distance. It's down low to the horizon. As you watch the moon, you're going to slowly turn your feet to the right, lift your head up. As it goes past you, this is hard to do one person. I need a cameraman here. So I'm watching the moon go around. I'm spinning my feet, my toes are going, and then now it's going to get over to the west, and I'm going to tip my head back down. That will give you field rotation. This footage was taken over 4 hours with that same Celestron 2-axis mount I just showed you. The apparent rotation of the moon is field rotation, and it has to do with the changing perspective of the camera over the course of many hours. The huge jump you just saw was because my time lapse had ended and I didn't realize it until much later. By the time I restarted the camera, the moon had already field rotated quite a bit. The same thing happened when Rich and I caught the lunar lurch, jump, leap, or whatever you want to call it. So now let me explain that. I wanted to point out what happened, why we got a 7-minute gap, is when with the P900 and the P1000, when you start a time lapse, it'll go 50 minutes. You'll see it count down, and it'll say 14:30, and then 10 seconds later 14:20, and so forth. This is the P900. The 1000, actually it's upside down here, but the 1000 actually counts the seconds down for you. But either way, they both only allow you to go 50 minutes, and then the camera stops taking pictures and you've got to push the shutter again, and it'll start another 50-minute segment. Well, normally what we'll do is we'll push the shutter, and then we tell our phone, okay Google, set the alarm for 48 minutes. The alarm will go off, we'll go back, make sure that we're over by the camera, and we'll watch it count down that last few seconds, and then we'll hit the shutter again and keep it going. Well, we went through that night, I think 6 or 7 time lapses, and every single time we set the alarm. Well, the one time we restarted the cameras, we were talking about something, I don't know, but we were heavy into some conversation, and we just simply forgot to say, okay Google, set the alarm. We got out of the car, went to see if the moons were still in both of our cameras, if they were tracking good, and we realized the time lapse had ran out. At the time, we didn't know how long that had been not shooting, but the EQ mounts were still running, so the moon was still in the middle of the viewfinders. It's just that the camera wasn't taking any pictures. So we just hurried up, hit the shutter again, started a new time lapse, and figured, well, we'll sort it out later. Unfortunately, when we got the footage back and we put all the files together on the computer, the jump happened during that time that the camera was not firing, and it turned out to be 7 minutes.
Despite the terrible timing, the important part is that the polar mounts kept tracking the moon. And here's why that's important.
This is the EQ mount. It's only got one axis of rotation. So I'm in Phoenix, so I've got it adjusted to 33 degrees north, I've got it adjusted 33 degrees altitude, and I've got this pointing due north. So even though it's daytime and we can't see Polaris, the center of this guy is pointing directly at Polaris. So as long as he's aligned on Polaris, the rest of this, the camera, will just keep rotating around in a circle, and it's only on the one axis, and you will not get field rotation that way.
This is the footage I was actually shooting on the P1000 I just showed you. This time lapse is identical to the ones Rich and I shot on February 16th, including the almost 8-hour length. The only difference in this one is that the moon didn't do a very rapid counterclockwise 20-degree leap. But let me make something very clear here. I could have turned off the camera for hours during this shoot, and although the moon would be in a different location in the sky, and the sky would be darker, the patterns on the moon would have remained in the exact same place, just like you can see they do with the camera running for the full 8 hours. The tracking is done by the EQ mount, and it will track the same whether or not the camera is taking pictures. So while it was extremely unfortunate that our cameras weren't running at the very time the leap occurred, had it not occurred, when we turned the cameras back on, the Sea of Crises would have been exactly where it was when the previous time lapse ended. In other words, the rapid leap most definitely happened within 7 minutes, despite our cameras not capturing it as it occurred. We honestly had no idea what we were in for. I mean, who ever heard of the moon jumping 20 degrees almost instantly before? We simply set up a couple cameras on EQ mounts and one just on a tripod because Rich saw something on mooncalc.org that made him think the moon was going to do something funky that night. Once the EQ mounts were aligned, that's where they stayed for the entire 7 to 8 hours we were there. And on the footage you're watching, you can see that the moon is dropping in the frame because the mount stopped tracking it properly. This was long after I'd gone to bed, and I'm not sure what happened, but the point is that the Sea of Crises remains in the same spot, even if the tracking is a little off. Anyway, I hope that helps some people to better understand field rotation, how EQ mounts work, and how it all went down the night Rich and I caught that lunar jump. And for those of you who follow the Mr. Thrive and Survive channel, you already know by now that we're far from being the only ones who have caught it. He's already presented a few other videos he found on YouTube that have these rapid moon rotations. I think there are probably dozens of them out there, already on YouTube, and it's just that nobody's ever looked for it before. Case in point, this discovery prompted me to review some of my past footage, and wouldn't you know it, it happened during the January 20th lunar eclipse. I was at the same North Mesa location where Rich and I filmed the other moon jump. The setup was identical,
with 2 cameras on separate EQ mounts. It started off cloudy, so I know it's hard to see it, but the Sea of Crises is top dead center in both cameras before the eclipse began. But look where it is about a third of the way through the darkening phase. It has rotated counterclockwise 10 degrees. And check this out. During the blood phase, I took a still shot with each camera while they were still on the EQ mounts and tracking. The one on the left was taken at 10:04 and the one on the right was taken at 10:06, only 2 minutes later. So the moon rotated counterclockwise another 10 degrees in only 2 minutes. Here's the first one, unedited with the metadata. And here's the second. And here they are side by side, so you can see the timestamps and the difference in rotation of the Sea of Crises. And you want to know the best part? I had 2 different videos of that lunar eclipse up on YouTube before I even knew what a lunar lurch, leap, or jump even was. It's been up there the whole time. Like I said before, I'm sure there's lots of them up there on YouTube. We just haven't been looking for it. But we are now.
Hello, Flat Earth researchers, debaters and debunkers. I'd like to demonstrate in this video how we can all make observations of the moon and the sun from different locations to see how they all fit together on this flat Earth. Here I have an illustration of what I see from Phuket, near the equator in southern Thailand, when the moon rises in the east from pretty much the same location as the sun. And you can see that if the moon has a shadow, it is on the top of the moon as it comes up from the east and reaches its zenith overhead, and then I have to turn around and watch it head off to the west in the same direction as the sun. But from my perspective, the shadow on the moon has flipped over to the bottom. So let's have a look at timeanddate.com. This was on the 23rd of August, and where there we can see the moon was at its zenith at 4:19 in the morning, and you can see the heading was 282 degrees west, pretty much direct west. And here's just another map showing my location with the cross and where the moon is said to have been at that time.
It's 4 a.m. I'm in my front garden in Phuket. The moon came up in the east over there. I am now going to lift the camera and show you the moon at its zenith, and you'll see while I'm heading east the shadow of the moon taking up the top half. Okay, the moon is at its zenith. Okay, moving down. Now I'm going to turn 180 degrees and now facing west, the direction the moon is going to head off in. Rising the camera back on the moon again, and the shadow now appears to be on the bottom. Okay, facing west, heading west, almost 90 degrees, turning around anti-clockwise. Facing east. Okay. Heading north, west. Okay. East. West.